In this video, we're going to be exploring square roots and cube roots. First, some definitions. A square root for a number n is x if x squared equals n. And then for a cubed root, same idea. For a number n is x if x cubed equals n. So using a small example like the number 2 squared, or to the second power, is 4. So the square root of 4, going backwards, is going to essentially be 2. Cubed root, 2 to the third power, well, you'll see that in a second. Let's take a look. First, square roots. Well, you see I've got a picture here. Why do you think we even call them square roots? Or when I raise something to the second power, we call it square? Well, really simple. We can make a square out of it. Here I have 16 individual squares, and all 16 of them can be arranged in the shape of a square. And when I ask for the square root, or the number that you would multiply by itself 2 times in order to get the number 16, is simply going to be the dimensions of this square, which is 4. 4 squared, or 4 to the second power, or 4 times itself, is 16. Pretty simple. This is where it becomes very useful for you to memorize those square numbers and cube numbers that I've talked about on another video. But there is something important about square roots, because what if I had taken the number -4 and multiplied it by -4? According to the rule of multiplication, if the signs are the same, they're both negative, the answer is going to be positive. And 4 times 4 is still 16. So if we have -4 being raised to the second power, you still get 16. So really, 4 is not the only square root for 16. And that's where I want to introduce you to this little symbol, generally referred to as the plus minus. It represents both the positive and negative of a number, where we can say that the positive and negative, both square roots of the number 16, are positive and -4. But sometimes you're really asking for just one of them. So how do we do that? Well, if we put a negative in front, that means we're looking for the -1. And if I don't put anything in front, that means we're looking for the +1. And this is the one that is referred to as your principal square root. If you were to type the square root of 16 into a calculator, it's only going to give you one answer, and it gives you the +1, the principal square root. And finally, I did include one other example on this slide. It is a plus minus, so we'll go ahead and put that sign in front. And it's 1/16. Everything looks about the same, it's just I made it a fraction. And just like exponents distribute over multiplication and division, so do roots. So this would really be, well, simply 1/4. Let's take a look at cubed roots. Have you ever wondered why we call something being raised to the third power a cube, and why taking the third root of it is a cubed root? Well, just like with the square, it's because we can arrange those boxes into the shape of a cube. Here I have 8 boxes arranged in the shape of a cube. Now you can see the 1, 2, 3, 4, 5, 6, 7 of them And there is an 8th one back in that last corner that we can't see. But that's all 8 of them arranged in the shape of a cube. And just like for when we squared it, we're really looking for the dimensions of this cube. And all 3 dimensions are 2. Which makes sense because 2 cubed is 8. But what about if we have a negative? Remember with the square root, we had to worry about the principal square root, and really there's 2 square roots, and the problem is going to be specific about which one is being asked for. But what about negative 8? Well, you can't even make a square number negative, can you? Because you're multiplying 2 numbers. It's going to be positive because they're the same. If we tried multiplying negative 2 times itself 3 times, what's going to happen? Negative times negative is positive, times another negative is negative. So here we can say that the cubed root of negative 8 is negative 2. So we don't have to worry about, are you asking for the positive one, or are you asking for the negative, or do you want both? For the cubed root, and truly for any odd numbered root, as you go into higher ones, because you can do 5th, 7th, 9th, and so on, the sign underneath the radical symbol does make a difference. And there's only one answer every time. But anytime the root is even, like 2 and 4, 6, 8, and so on, every single time you can only have a positive number being rooted, and there's going to be technically 2 different answers, and it's up to the context of the problem or how it was written to determine if you want both of them or just the principal root. So let's just do a few examples. This is really easy if you have memorized some of these numbers. The cubed root of 125, 5 cubed is 125. The cubed root of 64, 4 cubed is 64. And the cubed root of 27, well, 3 cubed is 27. And now let's move it down to these fraction problems. We already know what 8 becomes when you take the cube root of that, right? It's 2, and 27 becomes 3, 2/3. And that's why I chose these numbers up top. 125, we're doing the cubed root again. That's 5. 64 is 4. Is that the answer? No, not yet, because there is a negative in front, so we need to make sure that this is a negative 5/4. And then finally, this last one, 27, the cubed root of that is 3. 125, the cubed root of that is 5, and it's 3/5. Really simple if you take the time to memorize some of the most important cubes. And the same thing applies to the squares as well. The square root of 64, well, 8 squared is 64. Square root of 25, well, 5 squared is 25. So for this first one, we want both the positive and negative roots. We want both roots of 9/49. Well, the square root of 9 is 3, and the square root of 49 is 7. And then for this last one on this page, we only want the principal root. So it's the positive one. The square root of 25, we already said, is 5. And the square root of 16, we said earlier, is 4. Again, fairly simple if you do take the time to memorize some of the most common powers. So let's do an application of this one. You may be familiar with what a chess or a checkerboard looks like. There are 32 black squares on a chessboard and 32 white squares. How many squares along each side of the board? So there's 32 black, 32 white. How many squares are there altogether? Well, 32 plus 32, there's 64 squares, both black and white. And what is the shape of a chessboard? It is a square. What we need is the square root of 64, which is 8. And if you happen to have a chessboard handy, you could take a look at that and just count along the edges. That is an 8 by 8 square containing all of those individual small squares. Very simple. And here's another example. We have a box that's in the shape of a cube, and it can hold 8 cubic feet. What are the dimensions of this box? So we've got our box in the shape of a cube, and what it can hold is 8, but we want to know what the dimensions are, so we need to take the cubed root of 8, which, if you remember from way earlier, several slides ago, we know that that is 2, or 2 feet. And that concludes our lesson on square roots and cubed roots.